Hello and welcome to my bathroom. Now I know what you're saying, why Mr. Stone's bathroom? Well, I wanted to talk to you a little bit about our next transformation, the very first one we're going to study, reflections. And I happen to have this really awesome mirror right here. Now, when I was a kid, I used to look at the mirror and try and figure out exactly how I can maybe get through to the other side, or if there was like another stone that lived on the other side of the mirror, alternate dimension and all that. I was a very creative or weird kid, okay? But I thought about this a lot, and I think it's really interesting to think about that in terms of reflections. Now, it is the season for baseball playoffs, and one of the big things that they do in baseball playoffs is prank each other. At the end of a big game, if somebody had a winning pitch or a winning hit, some of the guys will look around the clubhouse for materials to joke around with it, and they'll make this nice shaving cream pie right in the face. So if I wanted to, if there was an alternate stone that lived in the other dimension across from that mirror, I would want to try and hit him with this pie because he's copying me and there's only one of me. But I couldn't, because every time I would try and get close, the other stone's same shaving cream pie would get right in the way. That is because one of the properties of reflections in the mirror and in geometry is that any point or any figure is exactly the same distance away from, we would call this a line of reflection in geometric terms. This is one of the big vocab concepts we're going to have, the line of reflection. And notice here how we've got 2 points and a line. M is going to be our line of reflection. Point A is reflected over the line of reflection to A, and it's got the little apostrophe there. We would call that A prime. Okay? So A reflected over the line of reflection M would give us A prime. Notice the distance is the exact same. For any reflection, they're going to have the exact same distance between the line of reflection and the point as the original. And the notation we would use for this is this kind of wild looking thing we've got right down here. The R stands for reflection. The little m beneath it is saying that we're reflecting over line M, which we've got up here. What we're reflecting is right here, this A. So we're reflecting point A over line M, and that will give us A prime, or in plain English, the reflection of A over line M is A prime. Again, the apostrophe there just stands for the prime. Now, 2 other pieces of vocab we have to look at here are our pre-image and our image. The pre-image is what happens before the transformation. And you'll notice this because you've got pre, before. Pre is a prefix, again with pre in it, that cues you up that it's what's happening before something happens. So the original is the pre-image, and our after result, after the transformation, we're going to call that the image. So remember, the pre-image comes first, and then the result is our image. Now, we've got another point here. We've got point B, and let's take a gander at this guy. So we know that it's the exact same distance away from the line as its reflection. So check it out, we've got point B is exactly 2 inches away from the line of reflection. So B prime is also going to be exactly 2 inches away. And here's something really cool coming up. Wait for it, wait for it. We can extend our compass like we've been doing with constructions. And go ahead and let's make an arc right on up here. We'll do the same thing with our original B. And we'll see that they come up pretty close to this line there. They should be exactly on the line, but I'm working with a little bit of a goofed up compass here. The point is that the line of reflection is going to serve as a perpendicular bisector to any line segment that we draw between a point and its image. So if this is a perpendicular bisector, what does this mean? It means that they're going to intersect at a right angle. And also, let's call this point where they meet at right here, let's call this P. We're going to have the same distance between BP and B prime P. So we can say BP, the length of BP is equal to length of B prime P. They're the same measure, and we can also say BP is congruent. Now we're not talking about length, right? We're talking about congruence. It's congruent to B prime P. Because, again, our line of reflection is a perpendicular bisector to the line segment that we drew between our pre-image point and our image point. So it's taken me a number of years to realize, as a kid, that there is no other stone that lives on the other side of the mirror. It is just my reflection. But if I tried hard enough, and I was creative enough, I could find a way to hit that guy in the mirror. I just had to be a little creative.